Right, displacement time graphs. So this shows displacement, i.e. distance from or towards a point against time. If we look at this part, the displacement is changing in a positive way up until this point here. So if I look at the gradient of this bit of line, I might say that that would be dy or possibly delta y, and this would be delta x. And in order to find the gradient of something, I would say that that was delta y divided by delta x, which in this case is the change in displacement divided by the change in time, which in this case will be 10 meters minus 0 meters divided by 5 seconds minus 0 seconds, which is going to equal 10 meters divided by 5 meters, which equals 2 meters per second. For this part, what we can do, let's move the camera up a bit. For this part, we can do the exact same thing again. So we'll call that gradient 1. We'll do part of the journey 2. So gradient equals delta s by delta t, which in this case equals 10 minus 10 for that over 10 minus 5 there, so that would be meters, that would be seconds, which equals 0 divided by 5, 0 meters divided by 5 seconds, which equals 0 meters per second. So a positive gradient is going to give us a positive speed. A flat gradient on one of these is going to give us a speed of 0. And on the last part, this part just coming down here, call this number 3, we are going to have number 3 gradient delta s by delta t is going to equal 0 minus 10 meters. That'd be final minus the end, final minus the initial, sorry. And then underneath that, 15 minus 10 seconds, which is going to equal negative 10 divided by 5, which is equal to negative 2 meters per second. So remembering that this gives us a velocity, not a speed, because we're talking about displacement, not distance. So that means that we have to have a direction, and we signify that with either a positive or a negative. Next thing that we've got to think about with these is what if it's not a flat gradient. So in the real world, this is more like the kind of graph you will get on a displacement time graph. So what we have to do is find the gradient at a point, and we do that by taking a tangent to the point. So this is the point that I want to find out the gradient of. I draw a tangent to the line there, and what I can do is find out that exact same information. So I would look there at delta s, I would look there at delta t, and I would find the gradient of this line. So here I'm going gradient would equal delta S by delta T, which is going to equal 200 minus 20 meters all over 20 minus 5 seconds, which is going to equal 180 meters over 15 seconds, which is going to equal 12 meters per second at that point. Because the gradient of this point is constantly changing, this means that the speed along this displacement time graph is also always changing. So those are the points you've got to remember for that.